are going to factor by using the graph is what's going to happen. So I'm just going to go over to Desmos, and I have 0 equals. What you're going to type into Desmos is y equals. And then we're just going to type the equation right there so we can see the graph. So x, and then to get a third power, you just hit shift and then the number 6. There's like a little caret button there. That's how you get an exponent. And then I just use the arrow key to just get back, like the right arrow key to get down on the level with the rest of the equation. So I'm just typing this in, x cubed minus 5x squared minus x, and then plus 5. Okay, and actually before I look at the graph, how many answers should the equation have? 3. Okay. So I know this should have 3 answers or 3 zeros, if you will. So let me pull this guy over. And remember, you guys, if you got a touch screen, most of you do unless you have a loaner or something, but you can manipulate this graph around like with your fingers so you can help see it better. Now, if you click on the graph, you can hover over the points, or if you actually click on the point, it will hold it for you and tell you what the points are. But if I want to know where x would set the y value equal to 0, you're literally just looking for where it touches or crosses the x-axis. In this case, it crosses the x-axis at all the points, but they're all just really nice numbers there. So I've got -1, 1, and 5, and so I can literally just come back to this. My actual answer is -1, 1, and 5. If it were to ask you to write this in the factored form, those zeros correspond to a linear factor. So like -1 would be x plus 1, 1 would be x minus 1, and the 5 would be x minus 5. And you could write those in any order. The actual answer to the question are the zeros, the -1, the 1, and the 5. But just in case if your question were to ask you what would that be in factored form, you could write that down right there. Okay, so that's why there wasn't much space for that graph. So this had all nice answers to it, and the rest of the questions today are not. So next one, I'm just going to do the same thing. I'm just going to go back over to Desmos, and I'm just going to type, see if I can get this on the screen at the same time. So I'm just going to kind of modify this. This is x cubed minus 3x squared minus 2x, and then plus 6. So I'm just going to kind of modify the equation I already had in there. And again, I'm looking for my zeros here. And let me pull this back over so you guys can maybe see it a little bit better. Or I don't know if that doesn't make it bigger. I don't know what it's just doing. Okay, now if you click on these, I should have 3 answers again, right? Because it was x to the 3rd. And I can see there are 3 real answers because there are 3 places that crosses the x-axis. However, 2 of those are garbage numbers, and if you have something that is a decimal, Desmos just defaults to 3 decimal places. So if you have something that's not like an exact, like a 0.5 or 0.75, I would not take that as an answer from you. I would take the 3, and I'm going to show you how to get the other 2 algebraically. So at least one of the answers will be nice. A nice exact value, like I have x is 3 here. Okay, so to get the other 2 algebraically, let me show you how to do it. All right, so I saw on the screen 3 is going to be one of the 3 answers. So 3 is a 0. That would correspond to x minus 3 would be a linear factor for that. What you want to use that to do is to help you actually break down that polynomial. So if I know that's a factor, I can divide that into the polynomial to help me break it down. So you can use long division or synthetic. Personal recommendation would be synthetic because it's a little bit easier for me, but that's just because I'm used to it. So if you want to use long division, God bless, I'm going to use synthetic. So remember, if you have x minus 3, you change up the number that you put on the outside to be the opposite of what it looks like. Or it is, if you got the 0 from the graph, you just use the 0 right from the graph. You're going to write down the coefficients of the polynomial, which are 1, -3, -2, and 6. And then just to review this process with you guys for synthetic, we don't have any missing powers of x or anything like that, so I don't have any zeros, just copied the coefficients. the very first step after you write it out is just take the first coefficient, which is 1, just write that underneath the line. Okay, now I'm just going to review this. You do not have to use a highlighter or anything. This is just what we did when we talked about synthetic. It's just been a little bit. So I'm going to take 3 times 1, and you put that in the next open spot above the line. So 3 times 1 is 3, and then you're going to add together the numbers that are stacked on top of each other. Now, in this case, this will be really nice, because -3 plus 3 is 0. All right, now, repeat the process. So 3 times 0. Don't write 3. I always do something like that because I'm an idiot. But anyway, all right, so anything times 0 is 0. So 3 times 0, that should be 0. And then just add the numbers stacked on top of each other. Now, since this is a factor, I should not have a remainder. If I'm using this to break down a polynomial and I get a remainder, I screwed something up. Okay, so my remainder should be 0 here, which it will be. 3 times -2 is -6. So no remainder there. Now, if you remember doing this, the first number you go actually kind of backwards. You go from the right to the left. So -2 would be your plain number or your constant, no x, and then you add powers of x. So 1 would have an x squared with it. What that means is the factored form of this, x minus 3, we got that factor because we saw 3 on the graph. And if I multiplied this by the result we just got, which is x squared minus 2, that would give me back the polynomial that I have there. And I'm just going to answer this. So we got 3 from the graph. The other 2 we saw in the graph, but they were kind of nasty numbers, and this is why. If I set x squared minus 2 equal to 0, I would add 2, and then I'd take a square root. This is going to give me those other 2 answers that were on the graph, plus or minus the square root of 2. I don't know if you guys remember looking at the decimal just now, but it was 1.414. If you actually take the square root of 2, that was the rounded version of that number on the graph, but I want to know the exact value. So I'd want you to break down, use the nice 0, which is 3, and then we're going to break down the polynomial, either using long division or synthetic. It's up to you. All of these you'll be able to use synthetic with. There won't be any like weird situations or anything. So you can use synthetic or you can use long division if you like that better to help you break it down. Is anybody having a question? Okay, let me have you guys look at, each one of these is just a little bit different. So let me have you guys look at this one. How many answers should I have to the polynomial in example 2? 3 again, right? All right, so let's look at the graph here. Maybe. All right, so I've got x cubed minus just x squared minus 15x and then minus 25. Okay, I'm going to scrunch my graph maybe just a little bit here. Okay. So I'm supposed to have 3 answers, right? How many of those answers are on the graph? 1. So what does that mean about the other 2 answers? They have to be imaginary. Okay, so we're going to have to use algebra for this one. So the other part of the graph doesn't go back and touch the x-axis. It only goes through at 5. So we're just going to use the 5. All right, and then let me come back over here. So 5 is 0 here. That would correspond to x minus 5 is going to be a factor. What you want to do, you're going to use that 5 and that factor x minus 5 to help you break down the polynomial here. So what we're going to do, if you have the 0 from the graph, that's what goes outside if you want to use the synthetic, or if you're thinking about the factor, it's the opposite. So x minus 5 would go in as a positive 5. Just write down your coefficients. You got 1, -1, -15, and -25. Now, if I did this correctly, there should not be a remainder when you do this, because I know from the graph that that x minus 5 should be a factor. So 5 times 1 here give you 5. Then you just add the numbers stacked on top of each other. So -1 and 5 would give me 4. 5 times 4 is 20. -15 and 20 is going to give me 5. And then 5 times 5 is 25. So no remainder. Constant is going to be 5, x is going to be 4, and x squared is going to be 1. So I didn't have anything else I could use from the graph. So what we have here, factored form, I'd have x minus 5, and then x squared plus 4x plus 5. That would be the factored form. That's as far as I could go with that. And then last period, you're like, oh, let's factor that. You're not going to think of factors of 5 that add up to 4. And I know that because I saw the graph and I didn't see it cross anywhere else. So the other answers are not real here. I know one of the answers, like I said, from the graph was 5. How would you use the x squared plus 4x plus 5? How could I use that to get the other answers? Exactly. You would set this equal to 0. You just want to use the quadratic formula on this. And it is at the top of the page if you guys forget it. On the note paper today, but I'm just going to do opposite of b, so -4 plus or minus square root 4 squared minus 4 times a value is 1 times c value is 5. Everybody over 2 times a, which would be 2 times 1 for this guy. You're going to get -4 plus or minus. Okay, now under my square root, I've got 16 minus 4 times 1 would be 4 times 5 would be 20. So 16 minus 20 is -4, and it should be negative, right? Because we said the two other answers have to be imaginary, so I should have an I in my answer, which this will result in that, and 2 on the bottom. Now, what is the square root of -4? 2i. Thank you, Bree, for raising your hand. It's so nice of you. I have some out-of-control people here that just shout the answer. No, I'm just kidding. All right, so that's a perfect square in imaginary land, so it's 2i. Now, can I reduce that? Yes, you can. Now, it has to be all three, right? The -4, the 2i, both terms around the plus and minus and the number on the bottom. All three of those have to be divisible for you to reduce that, but you can here. Now, I can actually divide both of those terms by 2. So -4 divided by 2 is -2. And then 2i divided by 2 would just become 1i. Or you're just not going to see a 1 written in front of it. It would just be a plain I by itself. These are your other two answers, because that plus or minus symbol actually gives you two things. -2 plus I, -2 minus I. The other answer was the 5 that we saw in the graph. So I've retotaled. Is anybody having a question? Okay. Yeah. If we flip to the back. Okay, these guys on the back are both 4th degree polynomials, so x to the 4th, so I should have 4 answers, yes? All right, so I'm just going to type these into my Desmos so I can look at what the graph should look like. So x to the 4th, I'm just going to put that in front, minus 10x cubed plus, plus 19x squared plus 40x and minus 92. You guys, I'm sure, are way faster than, oh my gosh, just put an F in here randomly. Okay. And minus 92. Okay. All right, so I should have 4 answers, yes? All right, now, I'm just going to scrunch my graph a little bit. All my answers here, because this graph crosses the x-axis in 4 different spots, all my answers here are real, but 2 of them are garbage numbers. All right, so like this is 3.586, 6.414, so I'm sort of like lame. I'm going to have to divide here to figure this out. But 2 of the answers are nice numbers, and I should have 4 total. So I'm just looking at this graph here. -2 is one of the answers, and +2 is one of the answers. And I'm just going to move my graph so I can write that on here. Okay. So -2 is going to be a 0. That would correspond to x plus 2 being a factor. Also from the graph, 2 was another nice number, 0. The other ones were decimals, so we don't want to write the decimal down. I want to get the exact answer, so I'm going to show you how to do that. Now, what this question says in the example at the top in the title, it says double divide, and that's what we're going to do here. We're going to divide the polynomial twice. Okay, this is totally not hard. It's just, we're just going to use synthetic division twice. You're just going to pick one of the zeros. It does not matter which one, and we're just going to use that first. So I'm just going to use that first. I'll just start with the -2. That's the one I wrote down first. And then I'm going to write the coefficients of the polynomial. So 1, -10, 19, 40, and -92. And again, because this is a factor, we should not have a remainder when we go through this process. And here's where I'm probably grabbing my calculator because a couple of these numbers might be a little bit big. So just bring down that first coefficient, 1 underneath the line. And then we're just going to multiply, add all the way down here. Negative 2 times 1 is going to give you negative 2. Add that to negative 10. This will be negative 12. Negative 2 times negative 12 ends up being positive 24. And don't judge me, I'm using my calculator. Okay, this is 43. Negative 2 times 43 is negative 86. And if I take 40 minus 86, that's negative 46. Negative 2 times negative 46 is positive 92, no remainder. Okay, don't write like your constant, your x, and all that like we've been doing in the other questions. What I'm going to do, I'm just going to scooch this up just a little bit. You're going to use the other 0. All right, so I'm just going to take the result that I just got. The other 0 I had from the graph was 2. And just use the result. So I got 1, negative 12, 43, and negative 46. And if you use the positive 2 first, we would have maybe different looking synthetic division, but at the end we should have the same answer. Bring down that 1. 2 times 1 is 2. Add that to the negative 12, you're going to get negative 10. 2 times negative 10 is negative 20. Add that to the 43, we're going to get 23. And then 2 times 23, 46, no remainder. All right, what I want to use is the result after the second time we did the synthetic division. All right, so there was no remainder. The 23 is going to be your plain number, your constant. The negative 10 is going to have an x with it, and the 1 is going to have an x squared. Okay, so here's what this means. I did my double divide, right? Gosh, I keep coughing today. All right, now my factored form then would be x plus 2, x minus 2, and then what we just got there, x squared minus 10x plus 23. Sorry, I'm writing too big. All right, so we should have 4 answers, right? So negative 2, 2, and then, sorry, quadratic formula. Because the other 2 answers we saw in that graph were nasty numbers, so that means that we have to use the quadratic formula to get them. So opposite of b would be positive 10 plus or minus square root negative 10 squared. 4 times a is 1, c is 23. Everybody over 2a, so 2 times 1. Okay, now, when you guys do this, you're going to get 10 plus or minus. Under the square root there, I'm going to get 100. 4 times 23 is going to give you 92. So it'd be 100 minus 92. So this is actually just 8. And then you're probably like, because I'm like, all right, so I'm going to break down the 8 real quick. So 8 would be 4 times 2 if I was using my biggest perfect square, or if you want to use a factor tree, please feel free. You're going to take a 2 out in front, that's the square root of 4. So 8 would break down to be 2 roots of 2. So this would be 10 plus or minus 2 roots of 2. Everybody over 2. And I know this is long, but you don't do anything with that radical. Just like cover it up with your pen or pencil or whatever. Don't touch it. If all 3 of the numbers around that plus and minus and in the denominator, if they're all divisible by something, you're allowed to reduce this. Those are all divisible by 2. This would simplify 10 divided by 2 is 5, plus or minus 2 divided by 2 here would just become 1 with that radical 2. You're not going to see a 1 written in front of that. It would just be written as the square root of 2. And that's those two other answers that we saw on the graph. It would be 5 plus the square root of 2 if you wanted to look at the decimal. 5 minus the square root of 2. I don't know if you guys remember this, but 5 minus radical 2, it's like 3.585. 5 plus the square root of 2, it's like 6.41. If I go back to that graph to show that to you real quick, those were the 2 decimals that we had on the graph. We're just getting the exact value by using the quadratic formula. Okay, is anybody having a question? Okay, I got one more, and then I'm going to shut up. Okay. I promise at least one of the zeros will be a nice number for any of these questions we're going to work with. Oh, I broke something. Okay, sorry. Gosh, I should not be allowed to operate a computer. Okay, we got plus 6x cubed. I can't even do this today. I'm so tired. Okay, plus 69x squared, and then I got 384x, and then plus 320. Where did I come up with these numbers? Okay, I bet the graph is nice when we get it going, though. Okay, so I'm just copying that real quick. I can't do anything today. All right, let's see here. Okay, then how many answers should this one have? 4, right? Because it's x to the 4th. Okay, so I'm just kind of manipulating this, make sure I'm not missing. I'm just kind of grabbing the x and y axis, but I don't think I'm missing any part of the graph there. I mean, I stretched that pretty good. So I crossed the x-axis at -5 and -1, but if I'm supposed to have 4 answers, where are the other 2? They have to be imaginary. That's what's going on here. Okay, now I'm going to repeat that process we just did. We're going to double divide. I can see 2 of the answers on the graph, -5 and -1. All right, let me pull this back so I have some space again. And it doesn't matter which one you use first, and this one will be way easier than the question we just did, I promise. So I had -5 and -1 from the graph. Okay, it doesn't matter which one. Pick 5 or pick the -5 or pick the -1. It doesn't matter which one you do first or second. I'm just going to do the -5 first because that's the one I wrote first. All right, I'm going to write the coefficients. So I got 1, 6, 69, 384, and 320. These are all positive. And you just bring down that first coefficient. If anybody wants to use long division, you're welcome to do that. I'm just using synthetic today because it's a little bit faster for me. -5 times 1 is -5. Add that to 6. So that'll actually give me 1 again. -5 times 1 will give me -5 again. Add that to the 69 will give you 64. -5 times 64 is -320. Add that to the 384, you're actually going to get 64 again. And when I multiply that by -5, I'm going to get -320 again. All right, and we should not have a remainder. Okay, if I got 2 zeros from the graph, what you're going to do is you're just going to double divide. So don't write down like your constant x squared. Don't write that down. Take the next 0, which was -1. Just write down, you've already broken it down once. We're going to break it down again. So I'm going to use the result that I just got. So just the 1, 1, 64, 64. You bring down that very first term, so this is a 1. -1 times 1 is -1. And then this makes me happy because -1 and 1 is 0, so I know one of those terms is going to be 0. -1 times 0, don't write -1. I did that last period on accident. Okay, -1 times 0 is 0. Anything times 0 is 0. I don't know why I screw that up with synthetic sometimes. This is 64. -1 times 64 is -64. Done. Okay, now I used both zeros, so I did a double divide. The 64 is your constant. There is no x, and there is an x squared. All right, so here's what this means. Our polynomial, factored form, you'd have x plus 5, x plus 1. Those were the 2 we saw in the graph. This is nice for us. The leftover is x squared. This is plus 64. Now, we couldn't see the other 2 zeros on the graph, so we know they should be imaginary. I got the -5, the -1, and then x squared plus 64, if you set that equal to 0, you would subtract the 64. That's what's going to create the imaginary number, because I'm going to take square root of a negative. Square root of -64 would be what? 8i. There you go. So the other 2 answers, plus or minus 8 with an I. We didn't see them on the graph, so they had to be imaginary. So I've got 1, 2, and then 3, 4, and I should have 4 answers to that question. Okay.